Today we're doing a lesson on direct current. Um, Most of this will be relatively straightforward and easy, and most of you will have seen most of this before. I just want to make sure that we all have the same framework and baseline before we move forward. So to begin with, you should know that when talking about electricity, there's two basic equations. There's volts equals current times resistance, and there's power equals uh, current times volts, or current squared times resistance. So these are the two main equations that we'll use when dealing with electricity. And these are the ones most people know. However, we're going to dive a little bit deeper to learn a little bit behind what's going on with these, what volts are, what current is, and what resistance is, and what power is in a more basic way. So all these can be related basically in terms of coulombs or joules. So what is a coulomb? A coulomb is simply electric charge. And what is joule? It's an amount of energy measured in Newton meters. That's not newtons per meter, that's Newton meters. So what is a volt? A volt is our pressure differential. It's our power differential. It's our joules per coulomb. It's an amount of energy per electric charge. And what's current? Well, it's the amount of electric charge per second. And resistance is, while the units don't really help here, it's joules seconds divided by coulombs squared. It's your resistance. It's things that slow down, pull things out of the circuit. And power is our joules per second, or amount of energy per second. So this is the total output. This is how strong it is. So one way to think about how all this works, and you may have heard this before, is think about a pipe, closed pipe with a pump, and that's our electric system. So the pipe is the same as the wire. The pump is the battery, and the battery has, or the pump has a certain amount of pressure that it puts out. That pressure is your volts. So that pipe or the wire has a certain amount of pressure at the beginning, but as it goes through the pipe or the wire, it runs into various resistances as well as the natural degradation as it just runs along due to friction or discharges along the pipe or wire, however you want to think of it. So the pressure will gradually decrease or decrease in steps as it goes through. And the current, well, that's the current. That's the amount of water flowing per second, or the amount of charge per second that's flowing through. So your volts is your pressure. You start off with a high pressure, and then as you go through the pipe and you run into different resistances, your pressure is gradually decreased until you essentially have nothing left and you're back to um, come back around to the pump where it starts the system over again. So I hope that helps you understand something of what's going on. So we're going to use these relationships, the joules and coulombs and seconds relationship, and the problems we're going to work through today. I'm going to do one of them, and then I'll expect you guys to work through the rest. So number one says household current in a circuit cannot generally exceed 15 amps for safety reasons. What is the maximum amount of charge that could flow through this circuit in a house during the course of a 24-hour day? Well, we're talking about amps and we're talking about charge. Well, amps, we know up here, amps are coulombs per second. So we can set up a relationship where 15 amps equals coulombs over seconds. And we're trying to solve for charge, which is coulombs. So we have to change that 24-hour day into seconds. So we take 24 times for the hours times 60 for the minutes times 60 to get seconds. And we'll have uh, 86,400 seconds. Well, we still need to multiply that by our 15 amps to solve for coulombs, and that gives us 1,296,000 coulombs. And so that would be our answer for number 1. And I'm just going to point out that we have 2 sig figs for this. So this is the more appropriate answer.